A very good morning to all, dear students. Uh, Here, this is we are doing the video and sending to you. So, using this video, learn this session. So, let us, we have studied the previous class, that is the elliptic PD or a Laplace equation theory part is over. Elliptic PD is same as the Laplace equation. So using the Laplace equations and using the given conditions, we can find the solution. Let us, we can move to the solution. First, the example is like this. Obtain the solution by considering the Dirichlet's problem of the rectangle for uxx plus uyy is equal to 0. Uxx means dou square u by dou x square plus dou square u by dou square is equal to 0 with the following conditions. Here these are the conditions. U of 0 comma y is equal to 0, that is equal to u of a comma y. U of x comma 0 is equal to f of x. U of x comma b is equal to 0. Solution. So this is the Laplace equation. This is Laplace equation is also known as the elliptic equation. As you know that we have studying the three types: parabolic, hyperbolic, and elliptic. Elliptic equations are all elliptic equations are in the form of the Laplace equations. So consider the Laplace equation uxx plus uy is equal to 0. Now applying the variable separable method, as you know that in the previous classes, then the solution of this uxx plus uy is equal to 0 is it is in using the variable separable method, we can write u of x comma y is equal to x of x, y of y. So from this equation, we can find the uxx and uyy. Here I did in the here ux of x comma y is x dash of y. From this one, differentiate one time, you will get this one. Again, differentiate this with respect to x. Uxx is equal to x double dash of y. Like this, using the same equation, you can differentiate partial with respect to y. We'll get uy is equal to xy dash. Uyy is equals to xy double dash. Now uxx, uyy value substitute in equation 1. So we get in this form x double dash of x, y of y plus x of x, y double dash of y is equal to 0. The same equation we can put in the another form, x double dash by x plus y double dash by y is equal to 0. So here we consider x double dash by x is equal to minus lambda square, and from this equation x double dash plus lambda square x is equal to 0. Call this is equation number 2a. From this one, again y double dash y is equal to minus lambda square. So minus lambda square plus y of y double dash of y by y of is equal to 0. Then y double dash of y minus lambda square y of y is equal to 0. Call this is equation number 1. Our aim is to find the solution of equation 2a and 2b. Then the solution of equation 2a is, we get here it is in the form of, we write the auxiliary equation x double dash plus x is the d square plus 1 is equal to 0. Then d square is equals to minus 1, d is equal to plus or minus I. So here we get the roots are in the imaginary. When the roots are imaginary, we write the solution in terms of cos and sine. That is like this: x of x is equal to c1 cos lambda x plus c2 sin lambda x. Y of y is equal to c3 e to the power of lambda y, c4 e to the power of minus lambda y. From this one, this is the auxiliary equation like this: d square minus 1 is equal to 0. Then d square is equal to 1. Then d is equal to plus or minus 1. Roots are different here. One is plus 1, another one is minus 1. So we can write the solution of the partial differential equation in this form: y of y is equal to c3 e to the power of lambda y plus c4 e to the power of minus lambda y. The total solution is combining these two. As you know that u of x comma y is equal to x of x, y of y. So u of x comma y is equal to x of x is this one. This is the half solution. This is another half solution. We combining both together to get the full solution. So C1 cos lambda x plus C2 sin lambda x into C3 e to the power of lambda y plus C4 e to the power of minus lambda y. So using we have to try to find the solution in the three types when lambda square is greater than 0, lambda square equals to 0, lambda square is less than 0. Let us start the first case. Case 1, when lambda square is greater than 0, then equation 2 and equation 3 implies that we get the same equation. X of x is equal to C1 cos lambda x plus C2 sin lambda x. Y of y is equal to C3 e to the power of lambda y plus C4 e to the power of minus lambda y. So total solution will get u of x comma y is equal to C1 cos lambda x plus C2 sin lambda x into C3 e to the power of lambda y plus C4 e to the power of minus lambda. Call this is equation number 4. Let us move on to the second case. The second case, when lambda square is equal to 0, then the equation 2 becomes, equation 2 is here. Equation 2 is, these are the equation 2. 2a is also known as the 2, 2b is also equation 2. So from equation 2a, we get lambda square is equal to 0 means x double dash of x is equal to 0. This equation integrate one time, we get x dash of x is equal to C5. So again, differentiate that, integrate that, then x dash of x, C5x integration is x of x plus C5x plus C6. Here C5 and C6 are the integration constant. How we can find the solution of these two constants using the given conditions? So from the equation 2b, we get y double dash of y is equal to 0. Then y of y is equal to G7y plus C8. How will get it? As like this. Again, this equation partially integrate with respect to y 2 times, then we'll get this one. So the solution is u of x comma y is equal to, again we are changing, look here, x of x is like this actually. Again we got this x of x equation in this form, C5x plus C6, y double dash of y is y of y plus C7y plus C8. Then x dash of x value, y dash of value, substitute there. Then what will get u of x comma y is equals to x of x is C5x plus C6, C7y plus C8. When lambda square is less than 0, look here very carefully. When lambda square is negative, u of x comma y is C9 e to the power of lambda x plus C10 e to the power of minus lambda x, C11 cos lambda y plus C12 sin lambda y. This is equation 4a. This is equation 4. This is 4a. So now using the boundary conditions to find the constant values from equation 4, for lambda square is greater than 0, u of xy is equal to C1 cos lambda x plus C2 sin lambda x into C3 e to the power of lambda y plus C4 e to the power of minus lambda y. When x is equal to 0, u of 0 comma y is equal to 0. Substitute x is equal to 0 here. Cos 0 value is 1, sin 0 value is 0. This is as it is because we are finding the half solution. So using u of 0 comma y is equal to 0 is the boundary condition. 0 is equal to C1, C3 e to the power of lambda y plus C4 e to the power of minus lambda y. Now C1 must equals to 0 means this is not equal to 0 because lambda is here. This is a variable. So C is constant. So C3 e to the power of lambda y plus C4 e to the power of minus lambda is not equal to 0 means C1 must be equals to 0. Once we know that the constant value, substitute back in the equation. Therefore, when C1 0 means here substitute C1 0. The final solution after substituting the C1 value, u of x comma y is equal to C2 sin lambda x into C3 e to the power of lambda y plus C4 e to the power of minus lambda y. So put here x is equals to a here. Then u of a comma y, already this term goes to 0 because using this condition. So C2 sin lambda a put x is equals to a C3 e to the power of lambda y plus C4 e to the power of minus lambda. Now, look here, u of a comma y is equal to 0. This is the given condition. So, u of a comma y is 0 here. Then, here this is equal to 0. C2 sin lambda. Already we told that this is not equal to 0. Already here. So, this implies that C2 sin lambda a is equal to 0. C2 is not equals to 0. So, sin of lambda a must be equals to 0. And using the solution, sin theta is equal to sin alpha, or use 0 right in terms of sin, we can write sin n pi. This is holds good for all the values of n is equal to 0, 1, 2, and so on. So, sin get cancelled, lambda is equal to n pi. Then take a is right hand side, lambda is equal to n pi by a. Equation 4 becomes, look here, lambda value is known. Equation 4 is here, as I told, this equation. Wherever lambda is there, substitute that lambda value. Lambda is equal to n pi by a. So, u of x comma y is equal to C2 sin n pi by a into x, C3 e to the power of lambda y plus C4 e to the power of minus lambda y. That is n is equal to, lambda is equal to n pi by a is substituting here. Then u of x comma y is equal to C2 sin n pi by a into x, C3 e to the power of, again n pi lambda by a plus C4 e to the power of minus n pi by a into n minus n pi by a into y. Substitute lambda is equal to n. This is called equation number 5. So when lambda is equal to 0, the given condition is like this: u of x comma 0 is equal to f of x. So u of x comma 0 is equal to, put y is equal to 0. Then Cn is equal to, here put y is equal to 0. U of x comma 0 is equal to f of x, Cn sin n pi by into x, C3 plus C4 is equal to f of x. How it is? U of x comma 0 is equal to f of x you are writing. Why you are writing Cn? It is a n dimension. Cn sin n pi by into x, C3 plus C4. C3 plus C4 is equal to f of x divided by Cn sin n pi by into x. Call this is equation number 6. The solution is given using the linear superposition theory. That means here, using the superposition theory, the solution can be written in terms of n, that is the n dimension. U of x comma y is equal to summation of n is equal to 0 to infinity Cn sin n pi by into x, an e to the power of n pi by a into y plus bn e to the power of minus n pi by a into y. So here this is the solution in terms of the linear superposition theory, equation 7. Where again here Cn an is considered one constant, Cn bn is considered one constant. We can write that solution also. When y is equal to b, u of x comma b is equals to 0, u of x comma, given condition this is. Again using the superposition theory, summation of n is equal to 0 to infinity, an e to the power of n pi b by a. As I told here Cn an is also an, Cn bn is also bn. So bn e to the power of minus n pi by n to be sin n pi by a into x, where Cn an is equal to an, Cn bn is equal to bn. This implies that here u of x comma b is equal to 0 is the condition. So an e to the power of n pi b by a plus bn e to the power of minus n pi b by a equals to 0. Then write the bn value. Bn is equals to minus an e to the power of n pi b by a e to the power of minus n pi b by a. Then here this term you should take numerator e to the power of minus n pi by ba. It will get the e to the power of plus n pi b by a. So bases are same, e to the power of n pi e. Then adding the numerators, you get 2 times of n pi b by a. So equation 7 becomes, look here, Bn value is known. Equation 7 becomes this equation. 7 equations, substitute the Bn value. So equation 7 becomes u of x comma y is equal to summation of n is equal to 0 to infinity an e to the power of n pi y by b minus an e to the power of 2n pi b by a. This is as it is, e to the power of minus n pi by a into y, sin n pi by a into x. Then u of x comma y is equal to summation n is equal to 0 to infinity an. Take an is common here, e to the power of n pi y by b minus e to the power of 2n pi b by a e to the power of minus n pi by a into y, sin n pi by a into x as it is. This is called equation number 8. When y is equal to 0 here, substitute wherever y is equal to 0 here. U of x comma y is equal to 0. Here is also 0. Here is also 0. So here is also, here is no, there is no y. So it is as it is. So after substituting y is equal to 0, then u of x comma 0 is equal to summation of n is equal to 0 to infinity an of 1 minus e to the power of 2n pi b by a sin n pi by a into x, which is the half range Fourier sine series. Look here, it is a S is there, Fourier sine series, and constant an are determined. The constant an is equal to here. This an is finding this formula 2 by a 1 divided by e to the power 1 divided by 1 minus e to the power of 2n pi by b integral 0 to infinity, because it's half range f of x sin n pi by a into x dx. So this is the an value called equation number 9. Now equation 8 and 9 are the solutions of equation 4. This 9 and 8 equation of the solution of the 4. Now using the boundary conditions of equation 5, lambda square is equal to 0, lambda square is equal to 0. Then you will get u of x comma y is equal to c5x, c6, c7y, c8. U of 0 comma y is equals to c6, c7y plus c8 is equal to 0. C6 is 0. C6 0 means substitute immediately here. Then you will get only c5a, c7y plus c8 is equal to 0. C5 is 0. Then c5 is 0 means this is 0. Then u of x comma y is equal to c6 is also 0, c7 is 0. Substitute here. Back. C5 is also 0, C6 is 0. Then you will get C7y, C8. Look here, we are finding the separate solutions. Actually, suppose C6, here C6, C5 value 0, substituting back here, then it is a trivial solution. This is a, if this term is multiplied with this is totally 0 when after using the conditions, but you are finding the half solution in terms of, that is, only y is equal to 0. That is u of x comma y is equal to c7y plus c8. When u of x comma 0 is equal to f of x, this implies that, look here, u of x comma 0 is equal to f of 8. Here y is equal to 0. What is u of x comma 0? U of x comma 0 is f of x. Then c8 is equal to f of x. U of x comma b is equal to 0, y is equal to b here. U of x comma b is equal to 0, c7b, y is equal to here. c7b plus c8 is there, f of x is there, substitute here. Immediately, c7b plus f of x is equal to 0. Then f of x is not equal to 0. c7b must be equal to 0. c7b equal to 0 means c7 automatically 0. Then look here, c7 value is also 0, c8 is equal to f of x, then totally it is a trivial solution. U of x comma y is equal to 0 is the trivial solution. Similarly, using the boundary conditions, u of x comma y is equal to c9 e to the power of lambda x plus c10 e to the power of minus lambda x, c11 cos lambda y plus c12 sin lambda y. Substitute x is equal to 0. u of 0 comma is equal to 0. This is from the given condition. We can take 0, x is equal to 0 means u of 0 comma is equal to 0. Substitute here wherever x is 0. Here this value is 1, e to the power of 0 value, e to the power of minus 0 value is 1, c9 plus c10. Then here there is no x term, so this term as it is, c11 cos lambda y plus c12 sin lambda y. So this is not equal to 0. C11 cos lambda y plus C12 sin lambda is not equal to 0. C9, C10 must be equals to 0. So at x is equal to a, u of a comma y is equal to 0. C9 e to the power of lambda a plus C10 e to the power of minus lambda a. C11 cos lambda y plus C12 sin lambda y. Then this not equal to 0, this must be equals to 0. C9 e to the power of lambda y plus C10 e to the power of lambda is equal to 0. Simplifying here both the solution. Which solution? Where x is equal to 0 and x is equals to b. Now x is equals to a, x is equal to 0. We combining, then we simplifying, we'll get C9 e to the power of lambda a plus C10 e to the power of lambda is equal to 0. C9 e to the power of lambda a plus C10 e to the power of lambda is equal to 0. Then solving these two, this is plus minus 0. C10 is common, e to the power of lambda a minus, because we are subtracting, minus lambda is equal to 0. Here C10 must equal to 0. This is not equal to 0, nothing but this is must be equal to 0. Then C10 0 means C9 C10 must be equals to 0. Already C10 is 0. C10 0 means automatically C9 is also 0. Look here. Here is also will get the u of x comma y. C9 0, C9 C10 is 0, and this is 0. This is 0. This is 0 means you can multiply this. Back we will go back this one, this solution. C9 C10 is 0. Then 0 is multiplied this thing automatically 0. So for the given problem, equation 7 and equation 8 are the required solution, because these are the, and equation 5 and 6 becomes trivial solutions. Look here, equation 5 and 6, 7 and 8 are the required solution. Okay, this is the today's class. We can meet in the next class.